Normalization. So what is a normalization? You can say normalization of data can be looked as a process of analyzing the given relation scheme based on their functional dependencies and the primary keys to achieve desired properties of minimizing redundancy. See, when we do normalization, that means from a given relation we'll be having a lot of redundant values, or you can say a lot of redundant tuples. So in the process of normalization, we try to remove all those redundant values or tuples, so that the complete relation will be in a normal form where minimum number of repeated values are there. Okay, and minimizing the insertion, deletion and updation anomalies. So main aim is we want to minimize insertion, deletion and updation anomalies, because if there is a lot of redundancy, then we can get insertion, deletion and updation anomalies. Okay, and for this purposes several normal forms are proposed, like we have 1NF, we have 2NF, we have 3NF, we have BCNF, we have 4NF, we have 5NF. Okay, but in practice we only implement till 3NF. This 4NF and 5NF are not practically implementable, they are mostly theoretical, and this BCNF is proposed, that means it is recommended that every relation should be till BCNF, but practically we implement till 3NF only. Okay, so you can say most database system uses normalization up to 3NF. Now if a relation is in unnormalized form, then from that relation, if we remove all the multi-valued attributes and if you remove all the composite attributes, then the relation comes in 1NF, where every domain of every attribute is atomic. So you can say a relation is in 1NF if domain of each attribute contains only unique, or you can say atomic values, and the value of each attribute contains only a single value from that domain. Okay, that is, it will not contain any multi-valued attribute. Now from that 1NF relation, if we can remove all the partial functional dependencies, then the relation will come in the 2NF form. Now from the 2NF, only full functional dependencies are allowed. From the 2NF, if we remove the transitive functional dependencies, then the relation will come in 3NF. Okay, so after 3NF, we look at 4NF and 5NF. Okay, so we'll discuss about BCNF, 4NF and 5NF if it is required. So definitely we are going to discuss about BCNF. So let me give a simple example of 1NF. How can you get a relation into 1NF? So if you have unnormalized relation, assuming that we have the relation like this, this is an employee relation, this is an employee relation, and in this relation we have employee number, we have employee name, and we have contact as an attribute, contacts as an attribute. Assuming that we have two employees, employee number 1, employee name is A, and contact is 9821876102 and 9821876103. Assuming we have employee number 2, whose name is B, and contact numbers are 9821876104 and 98218761 and 06. Okay, these are the contact numbers that we have. Right now, this is an unnormalized form. This is not even in 1NF. To convert this given relation into 1NF, we have to remove all the multi-valued attributes. So here you can see contact is a multi-valued attribute, right? And we have to remove all the composite attributes. Okay, now to bring this table into 1NF, we have to make something like this: employee number, there is an employee name, and there is a contact information, right? So it will be employee number 1, employee name A, contact is 98, employee number 1, employee name A, contact is 99, employee number 2, name is B, contact is contact is 9821876102, 9821876103, it is 9821876104, it is 9821876106. These are the 4 employees. Now still the relation is not in 1NF because there are a lot of redundant values, or there are a lot of redundant attributes. To bring this relation in 1NF, we have to decompose it. That means we are going to create a table for employee, right? So here we'll be having employee number and employee contacts, and we are going to create a second table related to the employee, that is we'll be having employee number and employee name. Now this way we'll be having the minimum repeated values. So here we'll be having employee number 1 name A, employee number 2 name B. Here employee number 1 contact number is 9821876102, employee number 1 9821876103, employee number 2 9821876104, employee number 2 9821876106. Okay, now here this relation as well as this relation, both of these relations are in 1NF. That means you can say in case of 1NF we do not allow multi-valued attributes and we do not allow composite attributes. Here contact was a multi-valued attribute. To make it in 1NF we have to separate it, but in separation you can see there are a lot of repeated values, so we have to decompose the relation. We can decompose the relation, and decomposition should be lossless. It should be lossless decomposition. Lossless decomposition. In this lossless decomposition, you can see the common attribute is employee number and employee number. In the original table, employee number can determine name, right? So in this table, employee number is a key attribute, right? In this table, employee number is not a key attribute. Okay, so you can clearly see that employee number is at least a key attribute in at least one of the table. Therefore, this decomposition is lossless. Fine. Now after this, see every relation by default every relational database is in 1NF. You can say by default every RDBMS is in, or every RDB is in 1NF. Okay, so you can say relation is in 1NF if every field contains only atomic values, that is attributes of any tuple must be a single value or the null value from its domain, right? So every relation is RDBMS is mostly satisfying 1NF only. Okay, so that is why we are not going to discuss a lot of things about 1NF. So we'll start with the 2NF and we'll see how can you convert a given relation into 2NF, and from that 2NF how can you convert a given relation to 3NF. Okay.